Okay, YouTube Nation, we're cutting off the very front section. If you've seen the videos from before, we are not going to do the reasoning behind the law of cosines. We're just odd time here in Minnesota. We only have school twice a week generally, so that's currently when we've been running. So, but we're looking at solving triangles. And right now, we're going to start by setting up this triangle. I got angle A, angle B, and angle C, 26 degrees, 12, and 15. Give you a chance to write that down, and this is where I need some recognition from you guys then. Okay. Side angle side. Okay, excellent. So this is unique, right? So why can't we use the law of sines? Okay. All right, so good answer. The decision tree doesn't tell us to do so, but the decision tree was put together by somebody and by students who recognize you can't use the law of sines here. Why not? Yeah, you don't. Look. So, yeah, so Sam goes ahead and sets up, she's like, sine of 26 over A is equal to sine of B over 12. Well, you got two unknowns, right? So that creates a problem. So nobody ever told us. Everybody said, well, law of sines works awesome because we have an angle on its opposite side, but nobody ever said, well, what if you don't have that opposite side? What the heck do we do? Well, there's a formula. It's called the law of cosines. And I'll write it out for you. It says this: a squared is equal to b squared plus c squared. Does that look familiar? Looks like what? Pythagorean theorem. Pythagorean theorem works if you have a right triangle. Do we have a right triangle? No, so you got to add some stuff on. Minus 2bc times the cosine of angle A. I know. You see my pause for effect there? You know, it's like Pythagorean theorem. You're feeling good inside, but then you got to make sure you add on that last piece there. But the fact is that we can actually write the law of cosines not just for a squared, but we could write the same thing for b squared. See if you could tell me how I'd finish this off. B squared is a squared plus c squared. So I just interchange that to AC. Good. Excellent. So if you want b, you would write b squared just like that. Or I could do c squared is equal to what? Excellent. So law of cosines. That's our objective today, is to be able to solve these two types of triangles. The first situation that we have is side angle side. So if you go to your decision tree, sure enough, your decision tree is going to say, hey, we noticed what you got. You got the side angle side situation right here. It says one solution using the law of cosines, and that's where we're going to start. You guys told me it sure would be nice to use the law of sines, but it would require an opposite side. So let's find that opposite side. I'll set up an equation. A squared is equal to what? 15 squared plus, close, 12 squared minus 2 times 15, 12, cosine of, Emma. I was throwing it back at you because you loved that 26 earlier, so that's where the 26 goes. So the angle, where does the angle go in the formula? The end. Yeah, the angle is always at the end. The other components are always the sides. The angle sits on at the end. Now, your calculators are amazing because they are able to do order of operations. So if you just type it all in, 15 squared plus 12 squared minus 2 times 15 times 12 times the cosine of 26. Make sure we're working in degrees, not radians. Press enter, and the side length is 45. Why? Square it. Good. Square it. Answer 6.74. All right. So we've got A is 6.74. I've got some other things I can write in here. I've got angle A is 26 degrees. Got B is 12. Got C is 15. You got all those? Maya, you had a comment? What do you like about it? You just plug it in and boom, it's done. Okay, all right, okay. So let's all. This is crucial. Okay, this is where you gotta lean and focus a little bit here. So she makes a really good point. She says she wants to go back to law of sines, right? But let's consider her options here. She says the sine of 26 over 6.74, right, equals the sine of b over 12 or the sine of c over 15. And this is where you have choice. And this is where it's really critical, okay? This is the most challenging part today. If you can follow this, then you're golden. But the fact is it's hard to see this all the way through. True or false? It's possible that this triangle has an obtuse angle. True. Which angle would it be? Why? Because it's the biggest angle, right? Because it has the biggest side. Well, shoot. Suppose we set up the law of sines and we start solving for it. Your calculator doesn't know that. Why does your calculator not know the difference between an acute or an obtuse angle? Yeah, because sine is positive in the first and the second quadrant. Now, watch. How about cosine? Cosine is positive and negative. So cosine knows the difference. Sine doesn't. So if there's an obtuse angle for C, is the law of sines going to show it to us? No way. True or false? Angle B is acute. Can the law of sines handle us there? It sure can. In fact, the decision tree lays out this very specific point for you. It says, one solution using the law of cosines. When you use the law of sines then to find one of the missing angles, you need to start with the angle opposite the shorter of the two sides. Why? Because we're bringing out the acute angle, so then the obtuse angle will come out at the end. Do you see that? Because the law of sines can't find an obtuse angle. Good, you guys. You handled that exactly like I thought you would, because you are exceptional. You are exceptional. All right. All right, so what do I set up? Sine of 26 over 6.74 is equal to b over 12. Well, you guys have had adequate practice at that, right? I mean, yesterday you were sitting at home doing this, catching up from your e-learning and everything like that, right? Good job. So divide by 6.74. I get that. That's my answer, 0.78. No, what do I do instead? Inverse. So I inverse sine, and I get 5130. Can I find C? How? Awesome. So I got 180 minus that answer that you brought up, minus 26. 102. I think, no, I told you guys early on that you guys would say that this would end up being one of your favorite units. You like the solving of the triangles. Now let me just hammer the point home one last time. If I had the sign of that answer, look, I get 0.95 or 975. But if I would have set up the law of sines to find angle C, watch what angle it gives me. If I would have inversed that guy, I would not have come up with the 102. I would have come up with 77.3. See, it would find the acute one, not the obtuse one. So that's why it's important. We good? Awesome. Last example. What's different about this? I don't have any angles. So I've got A, B, and C, which I don't know. But then I have little a, little b, and little c, which we do know. Little a. Okay. So which of the 6 situations are we given here? Side, side, side. Awesome. So we've got side, side, side going on, okay? So the question is, where do we even start? Let's start with this idea. You could follow the decision tree. I know, but let's think about it first. Is it possible there's an obtuse angle? Yes. Which one would it be? C. Yes. It would be C. Can the law of cosines find an obtuse angle? It Can. So just start by finding the angle opposite the largest side. Start with C. So if you notice your decision tree, that's why it says, I actually have thought about just getting rid of that altogether and just focusing on this. Just start by solving the angle opposite the largest side. You could technically find a different one and still get it to work out, but it's easiest to just find the angle opposite the largest side. That way, if there's an obtuse angle, it's forced out. It can't hide. We found it. Okay? So, a squared, b squared, or c squared equals, whoop, I don't write c squared, 12.4 squared equals 10.5 squared, 9.1 squared. Ooh, that's a little bit different, isn't it? Because now we've got an angle sitting off by itself. Notice in this situation, we're not finding a side. We're actually finding an angle. Yep, you're going to have to inverse at the end. A lot of people just want to combine all this stuff together, but you can't. Because our order of operations says that, this is multiplying cosine of c, whereas this stuff is adding. Okay, so we got to be careful here. A lot of mistakes are made in this part. So I'll show you how we work through that. We got our 12.4 squared. We did 153.76. No, it's good to get an error. Then we see where our mistake was, right? And then I'm going to do 10.5 squared. Can I add on to that the 9.1 squared? I can. And I get 193.06. Can I multiply these three together? Sure. 2 times 10.5 times 9.1. Well, thank you. Watch this. Second entry. There it is. Go back. 10. And suppose you needed to insert something. Second INS. Insert. Or you just type it in as it was. Yep. I showed that to a different class, and it was like Christmas all over. They're like, holy cow. Can everybody see that the temptation right now is to take the 193 minus the 191? You're tempted to do that. But that's just like if you had 10 minus, or 10 equals 8 minus 5x. That's not 10 equals 3x, is it? No. We laugh, but folks, that's what we're tempted to do, right? Yeah, because we recognize what we've seen before. So what do I do? Yep, 153.76 minus the 193.06, and I get negative 39.3. Careful with the negatives. Negative 39.3 is equal to positive or negative? Negative 191.1 cosine of c. Now, the reason why that's really important is the cosine of c going to end up being positive or negative? Positive. So is it going to be an acute angle or obtuse angle? Acute. So if it was negative, then it would be obtuse. So it's very important to keep track of those negative signs along the way. So I take the negative 39.9. I divide it by negative 191.3. Oh, 0.1. Sorry. Is that my answer? What do? Inverse the cosine, and I get the grand total of 78.13. Tell me something about 78.13. It is acute. Tell me something else about it in context with all the other angles here. It's not obtuse. It's the only one we have knowledge of. It is the largest, isn't it? So is it fair to say that A and B are both going to be acute? Can the law of sines handle acute angles? No problem. So set it up for me. Sine of what? Okay. Sine of A over 10.5. Sine of 78.13 over 12.4. I hope that you become very efficient with this, that this goes really quick for you. Whoop, I'm going to go 10.5 sine of 78.3 Divide by the 12.4. Blech. For some reason, it just doesn't kind of work with my fingers today. All right, now what? 5596. And as Samantha said, we now subtract those from 180. 180 minus that answer, minus 7813. All right, typed everything in. You guys are being very helpful today in that regard. 4591. We got it? Okay, today's assignment, you're asked again to find area. We haven't had time to go over area in class. We're going to throw that in at some other point, so disregard the area question. But this now allows you to go through all sets of 6, doesn't it? Good work. You guys are great. Out.